This presentation will cover waves in the ocean, also known as swells. I will cover the two different types of ways waves are created and how we can apply the things we learned about waves in physics this year. Swells, or waves, are transverse waves that transport energy throughout our world's oceans. The way that the energy is stored or transferred is through transverse waves of energy in the ocean. The reason that the waves are transverse is because the water is displaced perpendicular to the horizontal movement of the waves in the ocean. The swells force the water up and down, creating the transverse effect of the waves. Waves created by wind or storms happen because of the friction of water and wind. So when the wind hits the water, it creates tension between the water molecules, which in turn causes energy to be released from the friction between the molecules. The speed of the wind and the distance for which the wind continuously attacks the water changes the force of these waves in the water. Not only are waves created by wind, but they are also created by shifts in tectonic plates. They are also known as tsunamis. Tsunamis are very devastating because they create rogue waves that are higher in height than most normal wind swells that travel long distances. These can ravage communities and destroy coastal towns. The traits and terminologies used to classify waves or swells in the ocean are very similar but slightly different to the ones we used in class to classify transverse and longitudinal waves. For the crest or peak or top of each swell, it is called the peak, crest, top. Different terms are used throughout the world in different oceans and different seas. For the bottom, it is called the trough, and the period is used for the length of swells. To find the height or energy in a wave, they take the distance between the peak or crest to the trough. The big difference between waves in an experiment or on the calculator and in the ocean is that they come in groupings or sets. This is due to the pulses in wind that are experienced during gusts. So waves of similar height will come in sets or groups together. This is important to know because especially during tsunamis, as stated before in my explanation of tsunamis, it shows that it's important to know that they come in groups or pairings, not only in the waves created by wind, but also in other types of waves. Now that we have the basics of waves down, here is an experiment I did to show how wind or air creates transverse waves in water. I filled up a bathtub and then blew on the water in the bathtub to create waves of energy through the water. Not only do waves have a direct relationship to physics through transverse or the type of wave that they are, but they also are a way that kinetic energy is transported throughout our world. So kinetic energy is a very important part of physics and our world, and waves are one of the ways that our world transports that energy throughout the oceans and seas.